Today, we're going to be learning inverse functions. I have a little diagram here explaining what inverse functions are, and I'm going to be using it to help guide your understanding. So, if we look here, a function is essentially an input-output machine. You take a value, we're using a in this case, right? So this is just a regular function, by the way, right? So we're taking a value, in this case a, right? And a is going to do some computation. So this arrow means that you're doing some sort of computation, right? You're computing something. In this case, we're using a mathematical model or an equation. And once that mathematical model or equation is done computing, we'll get an output of b. That's how a function works. You input a and you get b, right? And a, b are essentially x and y variables. So that is how a function works, okay? But now an inverse function, which is shown or denoted with this donation, right? So essentially, you're just going to add a tiny -1 up here. This -1 does not mean an exponent. An exponent is just a way of symbolizing an inverse function, right? So you know that this is inverse to a function, right? It's essentially going to do the opposite of the regular function. So this inverse function is based off of another function, but it just does the opposite. Okay, it does the opposite. So you can see here, I actually have shown that. So instead of inputting a this time, we're going to be inputting b, and we'll get the a value. Both of these are related, by the way. They're mathematically related or mathematically linked together. This means that if I have the input of a, right, in the regular function, that would be the output of the inverse function. If I had the input of the inverse function, which is b, I would have the output of the regular function. They're both related together, meaning that you could use any of these values to find other values based on your specific circumstance. All right? Cool. So now we understand inverse functions. Basically doing the opposite of a regular function, right? Because here we're taking the value of b and getting the value of a, while here we're doing the complete opposite, right? This is our inverse function. So let's look at an example of how we can actually achieve this, and that'll help you understand the meaning of it better, all right? So I'm going to keep this up for just like maybe 2 more seconds, just for you to kind of get notes. All right, let's move on. Okay, so let me go ahead and give you a function. Now, this is going to be our regular function, meaning it's going to be this function here, and then we're going to be turning it into this function or our inverse function. All right, so here we go. We have the value of f of x, which is going to equal 4x minus 7. I'm also going to give the value, this is going to be another function, of h of, let's say, a, which is going to be 5b plus 4. So we're going to do 2 different examples, okay? By the way, if you're not very aware of like what functions are, or maybe you need a little bit of a refresher, these are just like these values over here are just defining a function. So f is just a type or a function, similar to how you would assign values to a variable like x or y. This is just assigning this function to the value of f. Same thing here, h is just a function. Okay, so let's go ahead and figure out their inverses. I'll write them over here. I'll start off with the first one, and then I'll move on to the second one. We're probably going to need more paper, but that's fine. Okay, so f of x equals 4x minus 7. How do we do this? Well, first thing we need to note is that the value or the variable, which is shown in this format with the function declaration and also then the input. So our function, and then in parentheses, our input, right? This is going to be the y value, okay, or the output value. because it doesn't necessarily have to be the y value. It's just denoted as such most of the time. Like over here, you can see I don't have it in the y x value or the typical way you'd write it, but it's still nonetheless a function. But anyways, this is our output, right, of y. So let me just write that instead of this huge jumble because it's just much more easier to understand. So we're going to say y equals 4x minus 7. Now what we will do is we'll start isolating. Oh, sorry, not isolating, my bad. What we will do now is we're going to be swapping these two. So this is where the inverse really comes to light. So I'm going to even add a bullet point so you know. So now this is where we're going to be performing the inverse operation. We are going to be switching these two values. So this means that x will now be on this side and 4y will be on this side. Okay, we simply just swap these two values. That is it. Now what we have to do is, we're not done yet. It's not this easy. We're still not done. We have to solve for y now, because y will always be the output. Even though here I said that, you know, we're switching the input and output, in the actual function declaration, we still assume that y is our output. So therefore, we need to isolate y by itself. Okay, so how do we do that? Well, we will start off by removing this 7. So that we can just do by plus 7, so this cancels out. But since this is an equation, meaning that both sides equate to each other, they have dimensional properties, right? You're going to add a plus 7 here too. So this cancels out. So we're left with x plus 7, which equals 4y. So x plus 7, which is 4y. Are we done yet? No. And the reason why we're not done is because we want the value of y, not 4 times the value of y. So how can we do that? Well, we can do that by just dividing this by 4 and then dividing this by 4 as well. So this cancels out, and then we're left with x plus 7 over 4, which equals y. Now this y is actually a special type of y. This y is no longer f over x. It's actually f minus 1 over here over x. Okay? Now what does this mean? Well, it's basically the same thing as this, but with this simple change. And this just means that it is an inverse function now. Okay? So if we go back up here, the inverse function for this specific function is going to be f minus 1 x, which is going to equal x plus 7 divided by 4. There we go. By the way, sorry about the alarm. It was just my Pomodoro, you know, technique, but whatever. Okay, that is good. Excuse me. Let's go ahead and do this one as well. So I'm going to need to flip to a new page for this. So it is going to be 4a 5b plus. So HA equals 5b plus 4. Okay, there's our function. Let's go ahead and inverse it. So again, this is actually going to be the value of, oh sorry, this should be a, by the way, not b. Same thing here. This should be the value of a. That's my bad. That should be the value of a, because this a is actually the value of b, so it doesn't make sense to have the b over there. So that's my bad. Okay, so coming back here, so now we can just say HA is b, which is just our output, and it's gonna be 5a plus 4. So we're just making it a little bit simpler on ourselves. Now we swap again, same thing. I'm going more quicker here because you should know it by now. It's 5b plus 4. Now what we will do is we'll subtract 4 here, so we have to subtract 4 here, cancel this out, so it's going to be a minus 4, which equals 5b, then divide this by 5, divide this by 5, cancel this out, so we're left with a minus 4 over 5, which equals b, this again does not equal HA, but rather it equals H minus 1 equals A. And an easy way to think about it is because you're flipping to the other side, right? Because before you were doing, it was actually H over A and then the mathematical model. But now you're doing the mathematical model here, and then it's going to be H minus 1 equals A. Because you flipped to the other side. That's just a way of thinking about it. But yeah, that is the final answer there, over here. So it's just going to be A minus 4 over 5. So if I go back over here, it's going to be H minus 1 again, A, which is going to be A minus 4 over 5. Just double checking here. Yep. So those are the two functions inversed. If you want to see this a little bit better, here you go. And yeah, that is it.